Hi, in this video we'll see how to define logarithmic functions. Logarithmic functions are the inverses of exponential functions. Let's first review how to find the inverse function of a given one-to-one function. I'll take the following example. f of x equals 2x. It is a linear increasing function, so it is one-to-one, and it will have an inverse function. Because the inverse function should be one that undoes f of x, remember, inverse functions undo each other, then to find the inverse function we have to interchange x and y. But before that we have to replace f of x with y. Interchange x and y now. And solve for y. So f inverse of x is x over 2. Let's use the same steps to find the inverse function of the following exponential function. f of x equals a to the power of x. With the restrictions, remember the base a should be positive number that is not 1. Replace f of x with y. Interchange x and y. And solve this equation for y. This is an exponential equation. Yeah, but how to solve it if we can't represent the left side as an exponent with the same base of a? Here y is the exponent to which a must be raised in order to obtain x. We call this exponent a logarithm, symbolized by the abbreviation log. The number a is called the base of the logarithm, and x is called the argument. It is that logarithm with base a of x, or logarithm of x with base a, or base a logarithm of x. So for all real numbers y and x, when x is positive and a is positive and not 1, to use it for a base, y equals log with base a of x is equivalent to x equals a to the power of y. Note here that y equals log with base a of x represents the exponent to which the base a must be raised to obtain x. Again, logarithms are exponents. Note that logarithms can be found for positive numbers only, for positive arguments only. So, what is a logarithm with base 3 of 9? It is the power we have to raise 3 to in order to get 9. 3 squared will be 9. So, the equivalent exponential form of this statement will be 3 squared equals 9. What is the equivalent exponential form of this logarithmic statement? 5 raised to the power of third is 125. So note that the logarithmic statement and the exponential statement have the same basis. So we take the base of the logarithm and we raise it to a power, the value of this logarithm, because logarithms are exponents, to get the argument 5 to the third equals 125. What is the equivalent exponential form of log with base a of 2 equals 1/3? Remember, we have to take the base of the logarithm and raise it to a power the same as the value of this logarithm, and the result should equal the argument. What is the equivalent logarithmic form of this statement? It will be logarithm with base 7, which value is 2, or log base 7 of 49 equals 2. It is because 7 squared is exactly 49. We can use a logarithmic expression to define a function. In this case, it is called a logarithmic function. So if a is a positive number that is not 1 and x is a positive number, then f of x equals log base a of x. Define the logarithmic function with base a. Remember, we solved this problem a few minutes ago. We tried to find the inverse function of the exponential function f of x equals a to the power of x, with the requirements a to be positive and not 1. And after we did it, that's how we define the logarithm, we see that we get actually the logarithmic function for a solution. So I can write here that f inverse of x is log base a of x. The exponential and the logarithmic functions are inverses of each other. For example, if we have the exponential function 2 to the power of x and the logarithmic function log with base 2 of x, and graph them by setting up a table for each one on the same coordinate system, we'll see that both graphs are symmetric with respect to the line with equation y equals x, because they're inverse functions. The red graph is the graph of the exponential function, and the blue graph is the graph of the logarithmic function. And note that when taking values for x or for the logarithmic function, we can only use positive numbers because logarithms are defined only for positive numbers. The domain of this logarithmic function will be the set of all real numbers that are positive.